Okay, and we're back. Get out of here. And we're COMP100, and it's week 9, lesson 9, part 2. And we just finished off talking about binary search and sorting method. That's what we did. There's also the reverse method, and I don't see this as useful, this reverse method. And what it does is what it says. It reverses the order of items in an array. So I guess not as popular, definitely some uses. And again, they've given you some examples here of how you want to reverse the order of the array. So you want to kind of make a descending or ascending, sort in ascending or descending order. Because remember, sort sorts everything in ascending order. Reverse changes the ascending order to descending order, if you want to. Okay, so that's what that does. I'm not going to go into it. Here's something I'm going to mention, but I'm not going to cover. All right, and this is the first thing. So Neil is going to say, but isn't this what you're doing always? You're saying that the guys don't cover it, and we're going to say the same thing, Neil, because you're here. Since you're here, I got to use you as a thing, right? So did you guys learn multi-dimensional arrays in COMP100? Multi-dimensional arrays is like a single-dimensional array. Single-dimensional array is when you see a structure like this at the top. See how this is right here? This is a single-dimensional array of integer. That's what this is. But we can actually do multi-dimensional arrays, and they have a different syntax altogether. It looks like, for example, if you want to make a table, you can do this. See the square brackets? There's 2 values in the square brackets instead of 1, right? So you can actually create an array that has multiple values. An example of this would be, it looks like this. Here's a multi-dimensional array, right? And it looks like a matrix, right? And if you notice, there's some blanks, the square brackets, a space, and another space. And then it says rents, and it's going to read in these values, right? And each value is going to be loaded into the array. To me, this is great, but I'll tell you, more often than we do it in real life, we try not to use multi-dimensional arrays very often. Why? They take up a lot of memory. They sometimes, from a management perspective, they're more difficult to manage. And nowadays, we can use single-dimensional arrays and lists a lot more effectively. So I'm going to talk about them so you can see the structure, but I'm never going to test you on it, and I'm not going to use them with you because they're not as useful. Okay? Not anymore. Here's a triple-dimensional array, so 3-dimensional array, right? So you have, if you notice the spaces here, we have a space, and a space, and then you have 3 dimensions, x, y, and z as an example, right? Huge, it's crazy. Right? And then we have something called jagged arrays, right? I'm going to mention it to you, but we're never going to test you on it. A jagged array is an array of arrays, which is another craziness. Yeah, you can do that, because remember, an array takes elements, and each element could be an array itself, right? So it's mad. Again, I would never do this, an array of arrays, right? But I'm going to mention it to you so you've heard it. A jagged array is, an array of arrays. Okay. And that's it for arrays. So I want you to know them, multi-dimensional arrays. So like in other words, there's 2 dimensions or more, 2, 3, 4, 5-dimensional arrays. You can go as high as you want. And there's also jagged arrays, which is an array of arrays. It's math. So again, is it useful? There are some structures, some data structures that require it, but for you guys, chances are you won't hit it for a while. So there's no point for me talking about it. I want you to hear the word multi-dimensional array, but I don't want you to really, we're not going to work with it too much. So let's move on from arrays. And that's it, my guys, my friends, from arrays. We're going to move on to methods. Methods is where we're going to get, I'm going to give you your new assignment next week. We're going to talk about methods a little bit more. Okay. We're into chapter 7 of the book now. Right? And when we look at chapter 7, we're going to talk about what methods are. So far, with everything you've been given, right? We started off with data types, with conditional statements, if statements, switch statements. You've learned all that kind of stuff. There's only limited things you can do with those things. But once you get into methods, now you can get into way more complex structures, right? And this is what I want to talk about here. We're not going to cover anything with UI. So even though the PowerPoint presentation says we're going to cover UI stuff, we're not going to cover it here, right? Okay, so what the hell is a method anyway? what it says here is a bunch of statements that perform a task, and they're kind of grouped together. So imagine you have a bunch of statements grouped together that you're going to call, and that you want to call over and over again, right? That's really what a method is. And if you see a bunch of stuff that we repeat over and over again, then you want to put that stuff that we repeat into a method that you can call over and over again. Okay, that's what a method is. Here's a main method. We see this main method again, right? Here's our main method, and our main method has a console.writeLine in it, right? Well, if you notice, I don't know why this is like this, but if you notice, right, our main method, take a look at our main method here, up here on the screen. Our main method is just what we normally would see. It has static void main, right? And it has stuff inside of it. We run a method every time we run a program, right? Let's start off a new piece of code. We'll actually do a lesson 9, part 1 code. Okay, so we'll close this solution down. We're done with arrays, right? You guys should know enough to do your project for sure. Your assignment number 4, you should know enough now. We've talked about arrays long enough that you should understand how to do things, right? Okay, we're going to go, and part of it is you're going to learn part of it on your own as well. You're going to try it out, trial and error, debug, and figure it out. Okay, here's our new project, and we're going to hit a console application again, but this time we're going to call it COMP100 Lesson 9 Part 1, because we're Part 1 of Lesson 9 now officially. And of course, this is all around methods. Well, take a look at this thing. We have a method right here. It's called the main method. We've been talking about main in the program. So we've always have a main program here. So this is our program class. We talked about containers before too, right? Here's our namespace. Our namespace is called Lesson 9 Part 1, right? Here's our class. The class is named program. And here's our method. The method is called main. And if you know, we always start our program, all of our programs, with the main method. We also don't need these things. Take a look. This stuff here, we can always take them out. We don't need them because we're not going to do some kind of console or true console command, like go into the console and call up our program that's going to be called COMP100 Lesson 9 Part 1. We're never going to do that, right? We're always going to run console applications from inside Visual Studio because they're just learning. They're really for learnings more than anything else. So that's one thing you have to look at, okay? I'm going to kick off a new GitHub folder here, and let's go into GitHub. And we're going to go into create new repository, and I'm going to call this COMP100 Lesson 9 Part 1. Okay, and of course we're going to have this new URI. I'm going to just make this new repository really quickly for you guys, and I'm going to go into home changes, and I'm going to say created VS C# project, just like we always do, and commit. And then we're going to go into home, unsync commits, and sync up with what we got going on. There we go. We're synced. Okay, so now you have my project up on GitHub. Okay, let's go back. So a method then is a collection of statements. So if I put statements in here, right? Take a look. If I go CW, right? And if I have this console.writeLine statement, let's do a bunch more console.writelines. Let's just copy this and paste it a bunch of times. Watch. Okay, so there's a bunch of statements. All of these statements are in the main method, and they execute when the main method is called, right? Now, you guys don't see the call to the main method, but actually, when you run this program, the main method is being called. We're going to talk about that, right? You can't see it, but actually in your Solution Explorer, there's other files in here that we never focus on, right? And these other files that we don't focus on, right, they actually call up the main method as the first method that runs. And we can look at assembly information and all that stuff. If I go to tools, actually, let's go to project. Let's go to the project menu for a second. This is a new menu item that we never looked at before. Do it with me. Go to project. And if you guys go to properties, right, this is what you get. You get the project manifest, right? If you look at the project manifest here, you actually see the default namespace. Right? This is what happens. You see the assembly name, which is COMP100 Lesson 9 Part 1. You can change all these things, by the way. You can also get the assembly information. If I click on assembly information, you get the title, the description, the company, the product, the trademark. You can actually put an assembly version in. You can do all this kind of stuff. It's part of every project that you do, and you probably ignore it all the time because you don't know it's there. Even you guys don't probably know it's there, right? But this assembly information it exists, right? So one thing it tells us is this is the default namespace, COMP100 less than 9 part 1, because that's what we called it. Let's look at our build. If I go to build, it says, okay, cool. It has the different options, and look what the output path is. My output path goes to bin debug. Now you don't see a bin debug folder in here, do you? Yes, but it's there. If I go here, right, to my collapse all, and there's next to it, there's something called show all files. If I click on show all files, I get my bin folder, and inside my bin folder, I get my debug folder, and inside there is my executable. See? Here's my executable right here. So this second thing inside my my properties, my project properties, tells me what my output file, my output path looks like. This is where it goes. I can change this if I want to. I would leave it the same for you if I were you, because otherwise, if you don't know what you're doing here, you leave it alone. Okay, let's go to build events. There's nothing in here. Let's go to debug. Okay, when we debug, we start the project. Okay, let's go to the next one. Let's go to resources. Okay, if I click on resources, it says product does not contain a default resources file. Click here to create one. We're not going to do that. It would work fine if you were actually here in assembly information, and if you were actually doing a Windows form application, you would see this resources area. Let's go to services. Okay, here's some services. Nothing's really checked in here. Settings. Doesn't have a settings file because we're doing a console application. Reference paths. We can add reference paths in here. Signing. We can add signing in terms of the way we click create our assembly information. Security, if you want to add security, and publish. And if you notice, we can publish. It tells us what the publishing folder is. It's called publish. Right? We don't have that anymore right now. And we also have a published version. Right? And if you notice, the versioning is major, minor, build, and revision. Right? That's the four dots. If you see a version that says 0.0.0.1, it's usually the first revision. Right? But typically we have like we don't have a major version. Usually it's a build, like a 0.0.1, and then it goes 0.0.2. Oh wait, we have to revise it, 0.0.21, right? We see those. That's how the revisioning works. And here's our code analysis, right? If we have any kind of code analysis, which we don't. So inside of our project, we have additional files that we don't normally see. And one of these files, right? So this is our, right here, this is our project properties is where I went. That project properties is actually defined in here. Here's my app.config file. Let's take a look at that for a second. App.config. If I see this, and I'm gonna make this larger for a second. It tells us a couple things too. It tells us that our supported runtime version is version 4 of the .NET framework, right? And we actually use version 4.5, the actual version. That's what app.config does, if you notice what that is. So I'm looking at all the files now that we didn't look at before. Here's our properties file. Let's look at our properties file. If I look at assemblyinfo.cs under the properties file, do this with me, Hattie, so you understand. Take a look at this, assembly info. In here, I have my assembly title, all the same stuff we saw in our project properties. If you notice, look at all these things, right? We don't need to touch any of these things. Okay, I'm just showing you that they're there, right? That your projects aren't just made up of the program.cs file. Your project is made up of a bunch of other files as well. Here's our references. We have a different library of references here. Okay, so we're going to leave all this blank. We're going to get rid of this and go back to our C# program because that's what really we care about. But in here, somewhere in our project files, right? We have a condition that tells us when we run our code, this main function in the program, in our main program.cs file, this main function is the first function that runs. The first main method that runs is this main method. Everything kicks off from here when we run our code. Okay. By the way, this works the same for this. This works the same for Windows forms. Like if you want to make Windows graphical user interface applications, everything runs through the main. Okay? So the main then is a collection of code that we have all bunched together. In this particular case, we have a bunch of lines of write lines, but these write lines are inside the main method code block. Right? We've been doing this the whole time. We've been using main, right? Okay, let's get rid of some of these. Actually, let's get rid of all of these. Let's go back. Okay, so again, we have this collection. So another reason for us to have methods, because we can separate our code. So one of the reasons we have methods is we want to take stuff that repeats and put them in a method that we can call over and over again. That's one reason. The other one is, because it reduced code bloat. Imagine if all you wrote, if all I could ever write was one big long string of commands, right? It would be on forever and ever, especially if it's a bigger piece of code. But with reusable code, that's what methods allow us to do. We can call upon this method body over and over again if we want to reuse it in different places, right? By grouping it together under a single name. Okay, so multiple commands in one single call.
Is it like schema?
No. What it used to be called, before it was called methods, in some languages it's called functions. And in other languages it's called procedures. So these procedures or functions or methods, as an example, they were something that it was a grouping of instructions that you could call. You call the head of the method name. Example would be main, and then every time you call the main method, it would run all the instructions again. Okay, so think about the power of doing something like that. Here's some stuff that you need to know about methods. Methods, and I'm going to test you guys on this probably next week sometime. Probably do a little quiz. Methods must include a method declaration, like main. It's got to be there, the name of the method. In the method declaration, you have to have a header, a method header, or a definition. And you have to have an opening curly brace. You need to have that in the method. You have to have something in the body of the method, even if it's nothing. So it could be 0 or more statements. And you need to have a closing curly brace. Let's take a look at that. Here's our method declaration, right? Our method name is main. We have a opening curly brace and a closing curly brace. We have a couple of other things too. Let's talk about those things. So you need those things. You also need to do a couple of other things. You have to also optionally declare the way of accessing. It's called an access modifier for the method. In this particular case, we don't have an access modifier because we're in main. But an access modifier would be another keyword in front of this that would say there's actually three main keywords as an access modifier would be public, private, and protected. Those are the three most popular keywords that we'd use. But we don't use that here in main. In fact, it would give you an error if you try doing that. Here's the other one. You could use the optional static modifier, and we're going to talk about what that is, right? And static is what we're using here. Okay, we'll talk about what's static compared to others. They do different things. Methods that are static and methods that are not static, they do different kinds of things. Okay, let's keep going. A method needs to have a return type. So what does this method return? In this particular case, what does it return? Void. Void means nothing. Our main method doesn't return anything right now. It returns nothing.
So if you were to type a statement inside a string or whatnot.
We've already done that many times. You and I have made all kinds of...
Void would go.
No, void's always there. A method doesn't return anything. It means when I call this method, it doesn't return, nothing comes back out of the method. When we call a method, we interrupt execution of our program, and we go into that method, right? And we come back to where we left. So let's say, for example, I call my method. I have another method. I'm going to define a method down here in a second, right? And I want to go there and come back. We're going to do that. Okay, we need to have a method name or identifier. We need to have opening parentheses. We need to have a list of method parameters, so stuff that we're going to send to the method. In this particular case, here's our parentheses. And remember, we had some stuff in there that I took out. So you can put some arguments or variables that are in here, or nothing. You can have an empty method call like this, right? Or you can put other arguments in here as well. And if I press the open braces, a lot of times methods will tell us that there's other options in here. Now, I'm defining my method here. My method of my main method. I'm telling C# what my main method has, what it's asking for, right? So I need to, and I also need to have closing parentheses. So my parentheses are these things, these round brackets, opening parentheses and close parentheses. These are all things I need. So I need my access modifier. I need my return type. Every method has to have this. I need to have my name of my method. I need to have opening parentheses and close parentheses. I need to have my opening curly brace and my closing curly brace. These are all things that I need for every method that I define. Part of my syntax or grammar, if you will, for the way we write methods. Okay, so this is an advanced, more of an advanced topic. After we get into this advanced topic for you guys, for methods, we can explode in terms of what we can do. And I'm going to give you a really cool assignment on methods where we're going to make a little game. Okay? Yeah, these guys get to do that, right? And the game that we're going to write is an adventure game. Okay, we're going to make a little choose your own adventure game we're going to create together. Okay? That's going to be your final assignment. We're going to kind of do one together. We're going to build up to it. Okay, let's take a look. So again, here's our method. Declaration is what we talk about. And here's an example of how it breaks down. This is kind of really neat. I like how they've done this thing when they kind of show each piece. So here's our access modifier. And again, the most common words that you'll see here is public, private, and protected. Public means it's accessible everywhere. Private means it's only within the class itself. Protected means even subclasses can take it. And you guys don't know what those things mean, but that's what's most common words are. There's other ones too. Optional static modifier. We'll talk about why we put the static modifier in there in the first place. Here's our return type. It has to be in this order, by the way, too. Here's our void return type. Here's our method name. Here's our optional parameters that go in here. Here, and this whole thing on the top is called a method header. All right? Just like we talked about the head of a loop, this is the head of a method, right? The header of a loop, the header of a method, the header of a class, all right? And this is our method body, the stuff that's inside of these curly braces. That's inside of a curly brace. That's the method body. So we're just kind of labeling everything and talking about what everything is. So when I start using this new vocabulary, right? These new labels that I'm talking about here, you guys should understand what I'm saying. Right? Because if I start talking about stuff and you don't get it, slow me down and stop me so you understand what I'm talking about. Because once we start talking methods, we can't go back. It's like you're biting the apple of, from the tree of, of knowledge. You bit it, that's it. It's done. You can't go back to not using methods again. Right? Okay. Let's talk about these optional declared accessibility. So here's some keywords. Remember I told you that it's not just public, private, and protected. There's other ones. There's protected internal, and then there's also internal. And we'll talk about some of these, but not all of them, because you won't use them all. Not in your early coding life. Later on, maybe. Okay, let's talk about that. So here's some accessibility. So public and private are the most common ones that you'll see from an accessibility perspective. And then look what it says here. Can methods contained in the same class access this method? If it's public, yes. Can derived classes access this method? Yes. Can assemblies or projects that contain these classes access this method? Yes. Can any class access this method? Yes. So if I have public, it's accessible anywhere. So public is not necessarily a great thing because sometimes you don't want to have every other class have access to my method. You want to limit it, you want to encapsulate the class, so only make it available to the classes that need to use the method, right? Or the scope we're talking about. Remember what the scope is. A scope where variables live and die is between these curly braces. So there's a scope here, there's a scope here, and there's a scope here. There's 3 different levels of scope here. We have the method level scope, we have the program level scope, the class level scope, and here's the namespace level scope. There's different scopes. If I declare something that's out here, it's accessible to all my classes. If I declare that something that's in here in my class, it's available to all my methods within the class. If I declare something that's in here, it's only available inside this method. And then I can also make it further. If I declare a for loop or a while loop, then I have another scope, this scope. And that scope this true value, whatever this thing is, only lives and dies inside that scope. And I can keep going. I can do another little one, like I do another while loop, right? And then this scope, within this scope, within this scope, within this scope. So you keep on going more specific all the way down as I nest my scopes. When I say scope, it's where a variable or method lives and dies. That's where it lives and dies, right? Once it leaves these curly braces, this while loop is done. Once we're done with the while loop, it's over. You never can go back. Once you perform this function, whatever this while loop tells us over and over again until this condition is no longer true, this while loop is finished and you can never go back to it, right? Unless you put it in a method and you can call that method again, right? So let's just get rid of this for a second. I'm just using it for illustration purposes. Private, on the other hand, is not accessible anywhere except for within the class. So private is almost like the opposite of public. Public is available everywhere pretty much. Private is available only in the class that you declare it in, right? So typically you can kind of turn on and off accessibility of a module or even a variable inside or outside of a class. And usually this is in a class level. We don't talk about accessibility within our main method because we don't do that. Okay, but this is the big question mark. What the hell is static anyway? Well, you can declare a method either static or non-static, right? If I make this non-static, right, that means I have to actually call, it has to be inside a class that I call. So a static method then can be called without referring to an object. I don't have to instantiate a new object. I don't have to make a new object of that method. It's always available to me, right? So instead, I can refer to my class, and we'll talk about that. I cannot call non-static methods. I have to instantiate the non-static method first, and it's got to be made from the class that I call. And again, if I use static and non-static in this context, you're like, what the hell is he talking about?
I don't static.
So here's a static method. Our static method is main, right? Because it's in my main class program, I don't have to declare program as an object, right? So when we use the method main, I don't have to create an object of main. Like for example, if I create an object of type random, we did this random object before. Remember, it looks like this, random, right? And we call it this random number, like rand, right, is equal to new. We use the new keyword, random, right? And then I kind of close it off. This is called constructor notation, right? And this rand object is an object. It's an object made from the random class. We don't have to do that here. Well, now, for me to access random, random is now an object. It has other properties, even though I've just created it. I can go rand dot, and I have access to a bunch of things here, right? I can't do that with main, right? And I don't need to. Because it's declared static, I don't have to instantiate it like this. Right? Otherwise, if I didn't have the static keyword, I'd have to do, every time I declare a class of anything, this class, I would have to instantiate my class in order for me to have access to my method inside the class. Okay, but we're not at classes right now, so don't worry about it. But just remember this, static is like, when I use the static keyword, I create a container that I can call from any place. I don't have to instantiate the class that the method belongs in. For now, that's all you need to know. So let's talk about that a little bit more. So again, static can be called without referring to the object. Instead, we refer to the class. So remember, my program, I can always do something like this. Because my program is a class, I can do something like program dot, and then I have access to something called main. Here's main, right? There's program.main, right? And I can call this. Now, what if I call main, this program.main within main? I'm actually calling this static method within itself, within itself, within itself. What this is called, if I do this, if I call main itself, within itself, it's called something called recursion. This will loop forever and it'll crash the program. So I'm actually calling itself within itself. I'm calling, when I call a method, I use this, the name of the method with 2 round brackets. So I'm actually calling main to run. It's kind of a confusing thing if you've never seen it before. For now, we're not going to do something crazy like that. You'll never see me ask you to do that. Right? But that's what, so static is just a way of thinking about, I can call this method without instantiating a class. And for now, primarily, we're going to make static methods. That's what we're going to do. So all of our methods you're going to see from now until the end of this course are going to be primarily static methods. Okay? Let's continue. Every method has a return type, right? And again, the default return type is void, but you have to put it in. Right? So you can't declare a new method. I can't take this void out like this. If I did, it would give me an error, right? I have to put my return type in here. I have to call it void. Void means main is returning nothing. If I change this instead of void, if I make it an integer, right? And it says, hey, not all code paths return a value. Well, you know what that means? I don't have a return statement. Return, number. Right? This is okay. If I have something else other than void here as my return type, I need to have a return statement with a number, some kind of integer. If it was a double, so I can make this a double, I'd have to change this to a double value, like 1.0, right? And what I mean by return is, right now nothing is calling main. The main program is calling main. So we're never going to need to return anything because nothing's calling main. It's just the code itself. When we launch our code, main is called as the entry to all of our entire program, right? That's the entry point, main, right? But we're not actually calling it from anywhere physically, not here, not us. Our code is being called, main is being called for somewhere in the back end to make our program run, but we're not actually calling it. So we're probably never going to have to change the return type of main. We can take this out and leave it at void. And that's why main, whenever you kick off a piece of code, we always see this and some stuff in here. Okay, so let's recap before we continue anymore. Make methods. Methods have to have a method header. The method header includes the name of the method, the type of return, what it returns. In this particular case, it doesn't return anything. Does it have some kind of, is it static or non-static? And in front of that, do we have a return of an accessibility type, private, public, or whatever? Okay. Let's go on. Okay, so again, in order for us to make a proper method name, it needs to be a legal variable name. I can't put a number. I can't start a variable with a number. I can't start a method name with a number. It has to be like, the same kind of way I declare a method, I declare, a variable. A variable's got the same name. If I make my variable my variable, and I use lowercase characters and uppercase characters, the same rules apply to method names. I can't just make any name I want. It has to be, I can't use special characters. I can't use those. The same kind of things that applies to variables. That's what this means. Okay. Okay, here's an example. I've got my main method, right? And if you notice here, it says I've got this the show welcome message. Here's my welcome message, and here's some right now. The method, this main method, is inside the class, right? My class is my program in this particular case. Here's my program. That's the class, and inside my class, I have the method. That's typically where methods are. Methods don't live on their own. In C# and in Java and other languages, they live inside of the main class, which is, in this particular case, we've called it hello class, but in our particular case, it's called program. I could always rename my class. We never do it, though, eh? I'm going to take away these other files. My class, which is called program.cs, I can rename this thing. If I right-click, right, if I refactor it, I want to rename. And I want to rename my class. Instead of calling it program, I'm going to call it my class.
I always change it.
Right? Well, you could, but I can go my class. Right? If I do that, it's going to say, do you want to change all references to this object? And I can put yes. And if I do that now, up here, it's called my class. Right? But it still works the same way. If I run this thing, it's still going to do what it normally would do. It's going to flash. It's not going to give me an error or anything like that. Right? And right now it doesn't do anything. It just generates a random number that doesn't do anything. It doesn't go anywhere. It's random. Right? But if I wanted to kind of show what this random number is, right, I can do something like this, a console.writeLine. And inside my random, I want to kind of print a random number, right? So I'm going to go random.next, and I can kind of put a number between, let's say, 0 and 100. Right? I'm going to print that out to the console. And I need to have something else in here. I need to put in my, my whole wait for key thing, right? So it's like console.writeLine, please, or hit any key to continue. Hit any key to continue. You've seen this before a billion times by now, right? And then, after we do this, we go to very simple console.read key, right? And our console.read key is going to listen for input. Okay, so if I run it now, it's going to show my number. Let me just change this so you can see how big it is. I'm going to properties. I'm going to go to my colors, white background with some black text, and my font is going to be Consolas 20. That's okay. 31. Yeah. Let's try it again. So 0 to 100, or 0 to 99 actually. Let's try it again. 29. Right. 81. Right. So what am I doing? I'm actually calling this program, my class, and I'm calling the main method over and over again. The main method's running all these pieces of code. That's what we've been doing every single time. We're not just running the program. We're actually calling the main method inside the program for it to run. So only these things that are inside the main method execute. Right? They actually get called, these things. Okay. Now you guys already know about main methods. Well, here's another method, and if you notice, there's another one that's outside of the code. Well, okay, let's write one for us. So we want to do all this stuff out over here. So let's write a new method. So I'm going to make another method. Ready? Static is the first thing we're going to write. Void, it's not going to return anything, right? And we're going to make it so it's roll random number, right? That's what we're going to call the method. Roll random number. Big long name, right? Brackets. And we're going to do curly braces. And inside roll random number, I'm going to take all this stuff. I'm going to copy it. This stuff, actually these two things. Roll random number. I'm going to cut it out. I'm going to put it inside here. Right? Now, is roll random number going to actually show on the screen right now?
No.
I'm making a method. This is the method. Here's my method name, roll random number. But am I doing anything with it? How would I get to this roll random number? Here's line 20, right? At line 20, I've defined my method. I'm starting to define. Here's my method header, roll random number, right? But will it ever get to this roll random number method? Well, no, not unless I call it within my main method somehow.
Then you would put roll random number?
Yes. So in here, you would call roll random number. And when I do that, before it gets to line 15 and line 16, it executes a call to roll random number. And then it actually goes through roll random number, and it executes these two lines and goes back. It returns control of the flow of my program back to line 14. So let's read it in sequential order. So when my program runs, I run my program, and it runs to the top, to number 11, let's say. Let's start at line 11. First, it does all these imports. These are all system imports that it's doing, all this stuff. It does all this. It declares my namespace. It declares my class. Then it hits line 11, and it says, oh, we're in the main method. This is good. We're going to run this method automatically, right? Okay, cool. And then we're going to go down to line 13. It says roll random number. So instead of going to line 14 right away, take a look. Here's 13. We hit roll random number. It's a command. It says, hey, don't go to line 14 yet. Go and run the stuff that's in this roll random number method. Run line 22 and line 24 first, and then come back here to line 14. And then go line 15 and line 16. So this will do the same thing that we did before with this stuff being up here. The control flow, the flow of our program shifts from line 13 out to here and back.
Can you call a method from a completely different program?
Mm-hmm.
Or would you have to call a class?
Well, it depends. If it's a static method, it's inside your namespace, yes, you could call it, right? But let's not look at that right now.
That's efficient, though.
Okay, let's look at this. So I've called my roll random number method once, and I do this stuff. Okay, let me roll the number. So roll it 40. Roll it 66. What if I want to roll this 10 times? Well, I can simply call this method 10 times. So instead of me having to do the same stuff, in order for me to roll this 10 times, there's two ways I can do it. I can do a for loop in here, running it 10 times, right? Or I can do a for loop out here, calling the method 10 times. Let's do that. So let's go like this. We'll go for loop, right? And then inside my for loop, I'm going to take my roll random number method and put a call. This is the call to my roll random number. I'm putting it in a for loop, and I'm running it 10 times. This is the least efficient way to run my loop, by the way. Remember? I should really be counting down. But let's leave it the way it is. So if I do this, it's going to do these two lines of code over and over again from here. I'm reusing the lines of code in this method over and over again in here. Let's try that. So bam. Oh, wait, it's all 50s. How come? How come this is all 50s when I'm running my code over and over again in this new random?
It's doing the same one. So if you want to get different numbers, you do the for in the other method.
Nope.
Method?
It's not that reason. The reason why is because see this random number that I'm declaring down here? I'm doing the random number over. I'm declaring this random number seed over and over again, right? And when I do a random number, I only need to do this at the top of my code. Okay, let's try this. If I move this now, if I cut it out of here and put it up here, right? Question: does my method roll random number know anything about this random RND variable? Is it in the same scope? Remember what scope was. We just went, let's do this exhausting thing on scope. Here's a scope, here's a scope, here's a scope. Does this random variable, is it available to this scope when I've written it up here? No, because it's in here. The only way this random variable would be available to this scope down here, there's two ways. If I made it part of my class up here, or if I passed it somehow into my method through a parameter. Let's do that. Let's pass it into my method as a parameter. And the way I would do that is I would declare a parameter, and parameters mean things I want to pass into my class. So this is where I pass values. I'm passing by value. I'm taking this random number. I want to pass it inside here, right? So I do that. I go here. Put it in here first. So pass it in there, right? Now it's going to give me an error because you know what? My method signature, this is my method signature that I've defined, doesn't take anything. I have to tell it that it takes stuff. So I got to do this. I got to say, well, random. I got to declare what type it is. It's of type random. It's equal to, right, a random number. So we're going to call this, we'll call this random number, right, to make it different. So you understand what I'm doing here. Okay. All right. So now it's not giving me an error anymore. Do you understand what's going on, though? That's the question. So here, I take the value of random. This is the new random object, and I'm actually putting it into the call for my roll random number method that I just defined down here, right? I'm just throwing it in here. So the value of random right now, it's a random number between 1 and infinity or whatever the hell it is, right? It's a random number seed actually. And it passes into, if I put it inside the parentheses, it passes into my roll random number method just like my control passes from line 17 to line 26. So then does it carry forward the value of random into my method. That's what we say when we call the roll random number method and we pass into it this random. It's almost like I'm passing the ball. So I'm passing you the ball. You're the new method and I'm the main, and I pass you the ball, right? When I pass you the ball, I pass you a value. And you know what? In order for you to get that value, you have to declare it in here to catch it. This passes it, but I can't catch it unless I declare it in here. And it has to be the same value. If you notice here, I declared it as a type of random. And so here I have to declare a type of random. Here I called it RND. But in here, in my local scope, I've renamed it to random number. But it's the same value. I'm throwing it to you, and it's going to be called RND. But here in your local scope, it's not going to be called RND anymore. It's going to be called random number. If I wanted to call it RND, I could. And this RND, right, and this RND are totally different. This one only lives and dies in this scope. It's a value that I'm passing in there. Whereas this one lives and dies in this scope. Okay, it's a little confusing at first. Let's try it out now. So run it. Bam, I get different numbers now. Because why? I'm not declaring that thing, this part here, over and over again. Now there's a way to do this where I can put this in here, right? Because I can put in a time value. Hey Ravina, do you know how to get the time value of the current time in milliseconds? The current time in milliseconds. Do you know how to do that? Let's go do the date function. So if I go date time dot, right? And if I want to say milliseconds, right? Like current date time. Let's see. I want to get the current date time in milliseconds. So how do I do that? How do I get the current date time in milliseconds? That's what I'm going to ask you. Look it up for me. Get the current date or the time from the system in milliseconds. I want you to tell me what that is. Because I can get the current time anytime I want, right? I can get the system time and put it and display it, right? It's just a method that I'm using off of the current date function, right? Now the great thing is, if you notice this random here, take a look. This random class takes values. If I open up the brackets, it tells me there's two different signatures, method signatures. When you see these numbers here, take a look. 1 of 2, it says this is one method signature that has nothing inside, doesn't take anything. Nothing is passed to this method, right? But if I go to the next method signature by pressing this arrow, it says you can also pass into it an integer seed. And this seed, we use this number to create the random numbers. But if I pass into it the time in milliseconds, and how many milliseconds are in a second? 1,000. That means every second, unless the loop is very, very fast, my seed is changing, which means even if I call this from inside my code, it's going to be different. But I need to get the milliseconds in order for me to do that. So let's wait. I'm going to wait for Ravina to show me the time in milliseconds. How do I do that? What's the date time function to get my time in milliseconds? Do you know how to do it? Just look it up. Look it up. Time in milliseconds. How do I do that? Okay, I'll wait for them to get that. But for now, it works, right? It keeps on generating these numbers, right? It generates 10 numbers. If I put 100, it'll call this function 100 times. Let's try this out. 100. Bam. And they're all different, approximately. Right? I'm calling this function over and over again. If I add other things in here, right? Like for example, I want to call other things. Like I want to call, as an example, instead of just my control.writeLine, I want to add in another writeLine statement. Right? Here I am. If I do this, right, now it's going to call these two lines of code. I'm just going to get rid of some of this stuff to make it nice and tight. I can call these two lines of code every loop. Let me try this again. Ready? Bam. Right, and if you notice, there's a bit of a space between each of these lines of code now, because not only am I calling this random number, but I'm also calling this extra writeLine. And I'm doing that just like I would put two of these, just as if I was taking these two lines of code and putting it in the loop, right? I'm just calling this one code here called roll random. So this call, when I say the word call, when I call my method, the way I call my method is I take the method name, I put it here, I send any parameters or any variables I want to send to it, I got to put in brackets. And of course, anything I'm sending has to be received in the same way. The sender and the receiver have to match. Think of it that way when it comes to methods. Sender and receiver have to match. You figure it out, your Ravina? Let's go back. Tell me, how do I do it? Print it. Just tell me. Date time. UTC now, yeah. Dot millisecond. Okay. Does that now what this does, it gives me a random number seed that's the current milliseconds for my date. So if I take this, right, because I'm getting a new seed every millisecond, and I put this inside my roll random number, even though I'm redeclaring it, I should get some random number still, right? Even though I'm putting the random number seed in here. And you see how I'm passing in random? Let me just not do that anymore. I'm going to take this away and take this away, right? Because I don't need to pass random anymore. Okay. And now let's run it and see what happens. So there's 100 numbers, and we get some duplication. How come we're getting duplication? Let's just take away this extra right line so you can see it. Let's take a look and see what's going on here. Hadi, what do you think? Are there some numbers that are duplicated? 59, 11, 64, 16, 68. That didn't duplicate. 20, 73, 25, 77, 29. That didn't duplicate. 8, 82. How come some numbers are duplicated? Because it's not fast enough. My loop is running faster than a millisecond. That's how fast it's running. Remember, we ran our milliseconds. Our loops can run like under a millisecond to run, right? So even though I'm counting the time, I'm changing my seed. I'm saying, look for other places for random numbers. Every millisecond, it's not fast enough. And that's why we can't declare, if we're doing it in a loop, even if we do this random millisecond thing, it helps. It definitely helps us. It makes it a little bit more random, but there's some duplication here. It's inaccurate. What we want to do is we want to take this random number seed and put it back up here, but only call it once. And let the random number use the same random number. The random number seed is actually almost like a series of numbers. When I declare a random number seed, right, and it'll be different every time, right, I want to follow that series of numbers. It's already pre-generated for you, the random number seed. It's hundreds of numbers already put in play. And as you go down to get the next random number, it's already been predetermined. That's why it's called pseudo-random numbers. They're not truly random. They're just the number based on the position of the time, typically. Now what I can do is I can declare this random number seed up here, and it'll be even more random because I've declared my own seed. Here it is. If I take this, put it back up here, leave this UTC millisecond time in here because I don't mind. It just makes it a little more random. And now I pass the random number value in here, and again I have to do the same thing I did last time, which is declare my random number seed that I'm passing in. Right now, if I do this, I go back out, and now you're not going to see any duplication. Pretty much more random. Right? So we do this because, from a random number perspective, this has nothing to do with methods. But it's good to understand how random numbers work because I'm going to get you guys to do random stuff all the time, and you need to understand this. Now you can use a random number seed like this, or you can leave it out. It's okay. Right now it's in the main function. You can declare it out here too. But for now, let's leave it the way it is because we haven't talked about how to declare variables out here. Okay. Okay, so again, this is an example of a method. Here's from the book, right? We have our method called main. We're also calling this show welcome message method, which is right here, these 3 lines. Now, certainly we could have called these 3 lines inside main, but we're doing it over here. Okay, let's continue. I can declare variables and constants inside a method, just like I would declare variables and constants inside of this for loop. Can I declare a variable inside this for loop? Certainly. And what would the variable, if I declare my variable, here's a variable, I'm going to make an integer called my variable, right, inside this for loop, right, and I'm going to assign it to 0. Can I access my variable, this variable here? Can I access it here? Console.writeLine, my variable. Ooh, wait, I don't have access to it out here. How come I'm getting an error? Oops. How come? I've declared it here, but it's not happening here, right? Why? Because this scope, I've declared my variable inside this scope, and it lives and dies inside these curly braces. It can never exist outside of this world right here. Think about this as like a little micro universe, right? These curly braces. You live and die in this universe. You never exist outside of it, right? So if that's true, right, then if I declare variables down here, example, I take the same thing. I take this integer, my variable, and I declare it down here in this method, right? Do I have access to it in the main method? No. It only lives and dies in this scope. Even if I declare other methods, it will never exist except for in this scope. It's important to understand this because that's the power of methods. Methods have their own variables, just like main has its own variables. The only way that my method, roll random number, knows about random, this number here, is because I've passed it in to the roll random number method, and it's received it here. And when I receive it, I don't have to receive it as I can give it another name. I can call it random here. It takes it and passes the value of this number here, and I can rename it in here. It doesn't have to be the same. In fact, you should try not to make it the same to avoid confusion. Like for example, this is a roll random number, and I just can call this roll random num, right? And this way, it's a random num, randnum. Here, rand num. Right, so we know it's a random number, right? And this random number, or which we'll call this seed. How about that? We'll call this seed. Guess what it is? And so we're going to go to seed next, right? It's the same thing, even though it's called seed. It's still the same value because I'm passing this value in here, and it's going to be renamed to seed in here. And by the way, this seed value, can I get seed out here? No, because when I declare something inside the head of my method, it lives and dies inside this scope. That means whatever I've called it in here cannot exist outside over here. Even though I've declared it inside the head and I'm passing it in, it's totally different. Whatever I call it here lives and dies in this scope. I'm going to keep saying it over and over again so you guys get it. You can never pass this out here unless, here's where the unless statement comes in, I have a return, right? The return statement, the return keyword allows me to pass things back to where I was called from. So here I have called roll random number, right? But if you notice, my roll random number returns void right now. I don't have a return type. But let's say I want to return the number that I'm calling, the number. I'm going to return an integer, let's just say, right? And here's my random number seed. And you know what? I'm going to put a return value, return, and I'm going to return this. Right? I'm going to, instead of printing it out, I'm going to take this, I'm going to return it. And instead of seed, I'm going to call it, just so we know what it is, I'll put it back just so it doesn't confuse you to random, just so that we know what it is, right? Oops. You still need to put a semicolon here, and you don't need this. Okay, so let's get rid of this. So I'm returning next, doesn't really do much, this function. And up here, I'm going to take the value of this whole thing, right, and put it inside a console.writeLine. So let's do that. So console.writeLine, right, open some brackets in here and take all this and put it inside here. And take the semicolon away because that doesn't need to be there. Okay, and let's see if you understand that notation. So what am I doing here? I'm saying console.writeLine, take the value that I get back from, that's how you read it, from roll random number, right? I'm getting the value that I'm getting back from this, which is just this. That's what it's returning back. But first, I'm going to send in, and this is how I want you to read it, but first, I'm going to send in this random number seed into here. It's going to be used to generate the random number, and then it's going to return back into the same place it was called.
What happens if you do two of them?
What?
Two
returns? I cannot. For every method can only have one return officially. That when you write the return, that's where the method comes back from. Now you can have more than one return, but the first one that's called takes you back to where it was called from. It's almost like this. Imagine myself, I'm a little bit of a fantasy crazy guy, right? I'm a fantasy nut. I love reading fantasy books, right? So imagine if you can teleport into a new world, right? And the new world is this roll random number world, right? It only exists, if I go there, I make a copy of myself there. I'm not really physically there. So for me to go there, I go, bam, and just teleport into this new world, right? And in order for me to get back there, I need to return, right? And the way I return is through this return keyword, right? I go back exactly where I was called from. So if I'm calling the function or the method on line 18, take a look. Here's line 18. I'm calling this method on line 18. Where I call it from is where I return to. So I call it here, I run this thing, and I come back here. So I put value into it, which goes here, generates this value, comes back here, prints it out. I can do it all in one line. To break this down more simply so you can understand it a little bit easier, let's make it a couple lines. So we'll slow it down a little bit for you. So we'll do this, okay? So instead of roll random number, we're going to call this number a result, right? I'll make it a local variable that lives and dies inside the for loop, right? So let's do that. Int result is equal to, maybe this makes more sense to you, roll random number random, and then I'm going to print out the result. Does that make more sense to you? My result then, this is why I'm getting an error. The result then is I'm getting back the result because of my return statement. I'm sending in the random variable, right? It's coming back out into result, this variable result, and I'm printing the result out onto the console. Let's run this thing. Bam, does the same thing. So one line of code, this one line of code does what I did in like 3 lines. So let's try again. It's all different. It's like it belches it out. Right? It does new ones all the time, right? Make sense? So this method is being called at this particular location. On line 18, this method is being called. It's being called, right, before, this is the way it executes, before it gets assigned to result. Here's result. Result says, I'm going to use the equals operator, right, to get the value of this whole method, right? The whole method has a value now. It's this. When I put this in here as a return type, I need to return that kind of return type, integer. I've told it I'm going to return an integer right here in the method header, right? And here I have to receive an integer. So the only way I can get stuff back out of a method is if I have a return. Otherwise, when it goes in there, it's gone. Never coming back. I throw something to a method, it goes into the method, it's gone. It's finished, unless I get a return. If I have a return type, then I can send something back, but I need to place it inside something with an equals operator. Okay?
I thought it was too slow last time.
What slow last time?
No. Like it wasn't doing enough numbers. Isn't that because?
What do you mean enough numbers?
Like it was
duplicating numbers? Duplicating numbers?
Yeah, like last time.
Because I put this random number generator, I put this inside here, and then even though it's calculating every millisecond, it's still not fast enough because my for loop is running faster than this can calculate new numbers. That's why you put it outside of the loop. Always. Okay, let's go back.
It's getting complicated.
I know. Isn't it nice?
A little bit, but it's also.
Okay, so again, scope is the area in which a variable is known. I like saying scope is the area that a variable lives and dies, right? When the scope ends, the variable is dead. Cannot be outside. Cannot live outside that scope. And again, there's a bunch of unlesses, all right? I'm going to put unless in front of that. Unless you make the variable public. And the only way you can make a variable public if it's inside of a class. That's not static. In this particular case, it is. So you can't use any modifiers. Okay, let's go to the next one. So here's another example. And we'll take a break after this example. Okay. Here's our class. It's called local variable demo. We have our main static method, right? And if you notice, we have this integer variable with it's an A, and it's worth 12. And I print out the value of 12. It's going to print out 12, right? Then I call this method with its own A, right? And go here, method with its own A. Well, it has a value of 354, right? And then it prints out the method, in method A, the value is 354. And it shows the same variable, A. And then when it comes back here, what value is it going to show out here? I want you to do this with me. Huh?
354.
Meh. This is the method. This is the scope. This is the scope of this A. Does this A live outside of this method, Hattie? No. It
So
lives
it's
and
like,
dies in here. This A has nothing to do with this A. Even though it's the same identifier, A, it's just a friendly name for a memory location. And this memory location that's inside here is different than the memory location that's outside there. There's no relation between this A and this A. The only way we can have this A live and be the same as this one here is if we pass it into the method with a parameter call, which we don't have here. So anything, even though I redeclare it here, if you notice I declared it here and I declared it here, when I declare this A, even though it has the same name, has no relation to this A. It lives and dies in this thing here. There's totally different scopes. If it returns A and you put it back, then it would work. Right, because we're not returning anything here, so in that case, no. Right. So the way it would work is this. If I want to have the same variable, let's do that example. I like that example. Okay, I'll do it like this. Okay, I'll make another little. I'll keep this the way we have it right now. Here's my read key, and I'll make another method. Right. We'll say static. Let's do this together. Okay, void. We'll call it method with its own A. Right? Method with its own A. I like this. Right? And then we'll declare A. Int A is equal to 365 for the number of years. Right? The number of days in the year. And we'll say console.writeLine, right? The value of A in the method. And then we'll do a string which we'll call string interpolation, right? And we're going to say A, right? Because this is this A that's going to print out, right? And we're going to do the same thing. We'll take this whole value here, copy, and we're going to go back over here to this area here after the loop, and we're going to go Control V. And we're going to say instead of A is equal to 365, A will be equal to 26, right? Make it different. And this is the value of in main. Value of A in main, right? Is this, right? And then we're going to call method with with own A, right? Method with own A. It's going to call this method down here. And it's going to come back to line 27. We're going to trace this in a second. And we're going to print out the value of A again. Right? And now this value of A in main, and you're thinking it should be 365, but actually it's actually back down to 26. Tell me.
Isn't it going to... So it's going to print 26 first, and then 365 and 26 again.
Let's try this out. The value of A in main is 26. The value of A in the method is 365. The value in main on the way back is 26 again. But, like Ravina said, if I say, before we come to this right line, if I pass A into the method, right, and here I receive that value, right, like for example, if I go int A, I can't do this anymore, right, let's just comment this out. So if I do this, and the value of A in the method is the same as the value on the outside, right, let's try this out. See? Now on the way back, right, we can do the same thing. All the values are the same, right? But let's say if I I don't do this, right? Here's this, right? And instead of doing that, sending things into A, let's say I return A. So I do one of these. A is equal to method with its own A. And of course, I got to change my return type to integer. And then I've got to also do a return statement here. Pull this up for a second so you can see. Here's my return type. I'm going to return A. Oop, I'm going to call A. And I'll put this back. Okay. Now, what's the value of A? 365. Nice. So twice. Right? So what we're doing is, as we pass control. That's what I want you to think about it. We pass control from the main method. When I call a method, I pass control from this method, main, as I go down. Let's read this whole program again. Imagine you got this program and you were tracing it with your eyes, right? And you're reading each line. Okay, the first line, random row. This new random. We're making a new random object called RND, right? We're using the milliseconds and time in milliseconds to seed it. Okay, that's on line 13. We go to line 14, it's a blank. We go to line 15, we run the for loop. Okay, right now the value of int when we first run the for loop is, or the I, is 0. So it's the 0, and we're checking to see if I is less than 100. If it is, loop, and then increase I by 1. Right? Okay, good. Let's go into this. Int result, we're declaring a new local variable inside the for loop, is actually, we're going to pass control here on line 18 first to this row random number, get the random number on line 37, come back to line 18 and put it inside the result variable. Then we're going to continue down to console.writeLine and print the result out, and then we're going to loop again. We're going to keep doing that over and over again 100 times. When we're done, we're going to go to line 24. We're going to declare an integer of A, which is 26. We're going to print that out to A, and then we're going to assign A the value of method with its own A, which actually runs first. Here's method with its own A. We're going to actually declare this local A, which is not related to this A at all, as 365. We're going to print it out to the console, and then we're going to return it with a return statement back out to this A. So in fact, we're saying this local A is equal to this A in main now, and then we're going to print it out, and it's going to be the same value as 365, which is where we declared it here. It's confusing, but the way you look at it is this: always look at the scope of your variable. Remember, scope. I want you, like, this has got to be a mantra for you. You got to recite this thing in your sleep. A variable lives and dies in the scope, right? It is only known, we only know about the variable inside of its own scope. The only way we can know about the variable or pass a value outside of its scope is either through a parameter coming into the scope or a return statement leaving the scope. That's the only way it can pass in and out, for now. Okay? Okay, let's take a little break. It's 9:32. We have about an hour left. And I want to take another break before we continue.